Hi there, welcome back to AC's 8-Bit Zone. I have a lot of upcoming projects and I need to clean this lab bench off so that I can make way for all this new work that I have coming up. So today I want to show you a CoCo 2 that I bought, and mainly we're going to be updating the joystick that came with it. It came with a Tandy Deluxe joystick that has a problem inside. We'll diagnose that and repair that today. And also I'm going to show you how to upgrade or convert a IBM joystick to a TRS-80 Deluxe joystick. So we'll basically be converting this into one of these. And have a couple things to show you inside the CoCo 2 while we're at it. And let's go ahead and get this started. I have some upcoming electronics projects that I need to make some space for on the bench. I'll be modifying CoCo 1 and CoCo 2 hardware and doing some experiments, so I need to make some space for that. There's a possibility that we'll be doing some work with an FPGA, and I think I'll be showing some surface mount techniques that I use. I could show you some of the ways that I solder the surface mount parts. I have various techniques where I use an oven or I just use a soldering iron, and we might do that. But first of all, we need to get this stuff out of the way. So let's first take a look before we modify this joystick. Here's a Color Computer 2 that I recently got. Notice it has the diagonal rainbow stripes. This is one of the latest Color Computer 2s that were made. I believe this is model number 26-3134B, and the B at the end of the model number usually indicates that this board may have the updated VDG chip in it. So if it does, it would have the 6847 T1, and the T1 on the end of that part number would mean that the VDG has the true lowercase character set. So turns out this one does have it. Often the 6847 T1 is marked with this prototype part number XC80652P. So this has the true lowercase. Let me show you how that works. Oh yeah, also this board could come with Color Basic or Extended Color Basic. So this was the lower model, and to put it in the mode for the lowercase, we have to do a couple of pokes. Poke 359, 57, and poke 65, 314, 80. And if it has the updated VDG, running this command should turn the border into green. Okay, that's a good sign. So hopefully if we press Shift 0, hopefully we're now in lowercase mode. Sure enough, we are. Okay, and then uppercase would look like normal. If we reset the CoCo, there's uppercase, and if we now Shift 0, we'll see the old reverse video, which was the old lowercase version. So that was just the special poke that you could enter was really the only way that I know of to get the CoCos that had this new VDG to use the lowercase. I don't think Tandy made it very public or did much with the ROMs or any software to take much advantage of that. I'm sure a lot of third-party software took advantage of it though. Okay, that's one thing. One more thing that I wanted to show you about this CoCo 2 is the RAM. So it came with 16K of RAM, fact, if we do a print mem, we can see how much RAM it had. Okay, of course we have to spell it correctly in uppercase. Okay, 14624. So I believe this is a 16K machine, and what it came with was a couple of 6416s, and I believe there are at least 3 ways that you can load RAM into this board. So this is the 6416s for 16K. You could replace these 2 chips with the 64K versions of them. That's one way to upgrade it. Another way would be to add a daughter board that plugs into these 2 white colored headers. And I have that in a couple other of my CoCos. And I believe a third way would be to populate chips directly into the board or into sockets. So I believe you could mount them in these unused positions here. Just thought that was interesting. There were so many ways that you could add RAM to this. And I believe the story has it is that the reason Tandy did this, it seems sort of complicated. Why not just pick one way to upgrade RAM and save cost, and that's that? Well, I think they were trying to hedge the RAM market back at that time, and there was a lot of volatility, and they weren't really sure which style of RAM chip was going to be the more cost-effective way to go to 64K. Would it be the 8 kilobit chips, or would it be the 32K chips? So they made all these options for us. Okay, now to the main event. And this is an IBM PCjr Joystick that has a 8-pin connector. And today I'm going to modify this and convert it into a Tandy joystick by replacing the connector with a 6-pin DIN. This is the kind of connector that you want. This is a 6-pin DIN with solder type connections. So if we open it up, here we have the pin numbers. They're labeled 1 through 6. Well, after opening the Tandy joystick, the problem with the one direction of motion was this arm was broken. So that's not uncommon for these joysticks. Frequently this part breaks. Fortunately, this one was only in 2 pieces, and it was cracked right through here. And I've used some super glue to place these pieces back together. I used some Loctite standard liquid super glue, and it's at least holding temporarily. I let that set for several minutes, and I'm also going to put a little bit of epoxy on here before I close things back up, and I'll let you know by the end of this episode how well that held up and if it seems like it's going to be a good mechanical fix. And I'm also going to use this joystick as the model for how to make the wire conversion, because the IBM PCjr joystick is going to have different wiring inside, as you'll see, and we'll use this as the guide. Okay, once inside the PCjr joystick, you'll notice some differences from a Tandy joystick. Well, first of all, let's talk about the similarities. They have the same potentiometer, they have the same mechanical pieces, everything mechanical is the same about them. But the wiring is where everything is different. So with the Tandy joystick, the potentiometer has 3 connections that are all used. I believe this is the 5 volts and ground, and then this is the wiper of the potentiometer. So I guess the 5 volts would be the red one, the ground would be the black one, and the wiper would be on brown. And on the other one, the wiper is on green. But with the PCjr joystick, you'll notice they only made 2 connections. So I don't know if the red wire is 5 volts. We could easily look that up and see. but it's not going to matter. I'm just going to make the wiring of this one match the wiring and the pin out of that one. One other little difference is there are a couple of capacitors on the PCjr joystick. We don't need those in the Tandy joystick, but I don't suppose they'll hurt, so we may or may not remove those. We'll see how that goes as we go along. Alright, well, let's go ahead and make the wiring conversion and convert this guy over to Tandy style. First, I'll cut the end off of this one. In the Tandy joystick, we have red, green, blue, black, brown, and white. Over here we have red, green, and instead of blue we have yellow, and then black, brown, and white. So they both have 6 conductors in the wire, so that's good. We will have enough conductors to make the original cable work then. Okay, so it's Tandy on the left and IBM on the right. You know what? I've had some fire buttons fail on these joysticks in the past, so why don't we just check the fire buttons right away. And those can be replaced if they're bad. That one's good. That one's good. Okay, I'm in luck on fire buttons. At least they work. Looking closely at the Tandy joystick, the black wire is joined with the braid wire or the shield. And on the IBM, instead of the shield joining with the black wire, it's connected to one side of each capacitor, and the other side of each capacitor is connected to the red wire. So I'm just going to remove these capacitors, and I'm going to copy the black wire to shield wire connection that the Tandy joystick uses. Okay, I'm going to expose about 1/2 inch or maybe 1 centimeter of wire of conductor on the black wires, and I'm going to twist them together and join to the shield. black conductor goes to the first fire button. Then both fire buttons are jumpered to black. So let's do that next. You just want to daisy chain the black wire to each fire button and each potentiometer to the first fire button. To the second fire button, and then to this end of the pot, this end and this end. Soldered my tweezers to the connection. Okay, the ground wire is complete and fire button 1 is complete. Let's do fire button 2. That was blue on the Tandy, which is going to be yellow on the IBM. And again, I'm just keeping the wire colors matching as much as possible just to make this straightforward. And you can use really any wire color matching scheme that you'd prefer. Okay, both fire buttons are connected. Let's connect the wiper of this pot to green. And the wiper of this pot to brown. Tubing in the middle of this one. The last connection we need to make is red, which I'm guessing is VCC, 5 volts. this end is done. Now let's see about the DIN 6 end of the cable. I have so many times done all the soldering and then only realized that I forgot to back the covering over the wire, the cable first. So definitely do this before you do anything. But I think we get so excited to make the solder connections and be done with it that it's so all too easy to forget that step. Okay, here goes the red wire. Okay, the middle one, pin 6, is the blue wire and the Tandy cable, which we were going to replace by yellow IBM cable. Right, that's going to be the brown wire. Okay, bottom left, it's pin 4, the white wire. Bottom middle is pin 3, the black wire. And green wire in the bottom right. Okay, it's time to test these joysticks. I'll plug the IBM joystick over on the left, and we'll plug the Tandy on the right. Oh, the video out connector had fallen out there. Okay, I have a program that we'll use to test the joystick. Oh, good. Okay, so, alright, so what we have is the joystick 2 will be the X direction, the Y direction, and the fire button. Okay, when I press fire, hopefully the fire signal goes low. Good. How about on the other one? Okay, that's working. And joystick 1. Okay, looks like it's reading. Okay, so if we go left, we go to 0. We go right, we swing all the way to 63. If we go up, we swing to 0. If we go down, so that's looking good. Fire button's working. And this fire button does nothing. That's the way it's supposed to be. I learned something new about these joysticks. That's on the fire button. Number 2 is on pin 6 of the DIN 6 connector, and that pin is not even wired to the board on the CoCo. So that's not ever used and can't be used as far as I know. Okay, so left, we go to 0, right, oh, it's binding a little bit. Oh, you have to make sure that these stay in the locked position. Okay, left, right, okay, 0 to 63, up and down, good, and fire button. Okay, they're working, so that was a nice conversion. There's another way that I can test joysticks. So in an earlier video I showed the Super 64 ROM pack that I have connected here, and I have another ROM version in bank 4 that is, I believe it's the old, it's an original Tandy Diagnostics program, and I can't remember if this is Diagnostics Original or Diagnostics 2.0. So it says it's diagnostic. I don't know if the number 2 would say Diagnostic 2 or not, but this is a nice way to test joysticks. So you can center with the thumb wheel and then draw around. Make sure you can reach all 4 corners. Looks good. And it doesn't do anything to test the fire button. So that's why I have the other program that I wrote in BASIC to test everything. And then the right joystick is red. That looks good. It moves full scale into all the corners. Great. This little test program does a lot more than test the joysticks. You can let it run through your basic ROM, and it'll do a CRC checksum calculation, and it doesn't tell you whether it's good or bad. It just says, hey, here's the checksum value, and then I guess you could go check a reference and see if that's the value that's expected for your ROM. You could do a RAM test, but to get this far, the RAM has to be pretty much working. So let's do a sound test. Nice test. Here's the keyboard test. So pretty much when you press a different key, it displays that key on the board, or it displays that key on the screen and plays a different sound. Pretty cool. Break goes back to the main menu, and yeah, so awesome. Chasing joysticks. Okay, good. Well, that pretty much wraps up today's episode. I hope that was helpful, and I know a lot of people have been able to find those IBM PCjr Joysticks, so I know there's been some swapping going on and some upgrading them. So a few people had asked how to do that, so I thought I'd throw a video out there to show how I convert mine. So hope you enjoyed that, and so I have a lot of upcoming videos, so make sure you subscribe and tune in for those. We're going to be doing some exciting electronics projects with the CoCo 1, 2, and probably 3. So hang in for that, and until next time, see you then.